right, let's take a look at our lesson on factoring polynomials. This is an extension off of our lesson on factoring quadratics. So let's kind of go through some guidelines that we want to keep in mind when we are factoring. So the first, just like with quadratics, we want to look for a greatest common factor. If we have a greatest common factor, we want to factor that out. That's our very first, just like in the previous technique, the very first thing that we would do. Then what we're going to do is next we're going to look to see how many terms the expression or equation has. If there are two terms, then we have, which is a binomial, if you recall, it's a binomial. If there are two terms, then we can do what we did last time, which is a difference of perfect squares. But we also have an additional technique for binomials, which is listed right over here. It's the sum and difference of perfect cubes. So we have those factoring patterns now as well. And so we'll do some examples on the sum and difference of perfect cubes to explain that. But that is another option. So we've got sum or difference of perfect cubes. Okay. Then if we have three terms, we will factor like FOIL. That's what we did before. And so with a polynomial, we're going to factor like FOIL. Remember, factor like FOIL is like with the two bubbles. I call them bubbles, you know, where we open those up. We would factor like FOIL if the trinomial, so three terms is a trinomial, if the trinomial is in the form, it's in quadratic form. What? It could be in quadratic form? Yes, let me show you what that is. Quadratic form would be like the variable, we usually use x to the 2a, that would be my exponent, plus or minus x to the a, plus or minus just a regular plain old number. So this exponent needs to be twice the value of this one, and this just needs to be a regular number. That's called quadratic form. Then the other option is if we have four terms, four or more, typically four terms, we're going to factor by grouping. So very similar to the other options that we had when we were working only with quadratics. So let's do some examples. In the very first one, we're just factoring only. Notice that I have a perfect cube, x cubed is a perfect cube, and 8 is a perfect cube because it's 2 cubed. So in order to match this factoring pattern for the sum of 2 cubes, I'm going to list what each variable would be. U would be the x, and v would be 2, because 2 cubed is 8. So then what we're going to do is we're simply going to substitute those values into my factoring pattern. So we have x plus 2, that matches this u plus v. Then we have x squared minus, then we would do 2 times x, u times v, plus v squared, which is 2, 2 squared is 4. And that's it. That's the factoring for that. This piece right here, this trinomial, is never factorable. There's never a time, if you're working with the sum and difference of 2 cubes, that you will be able to factor that second piece, that trinomial. It just won't work. So now let's take a look at this one. We're just going to factor. We're going to look for our greatest common factor. let's see, between 16 and 54, let's see, 2 is the greatest common factor. Between x to the fourth and x, it's x, and then y, there's no common factor of y. All right, so let's remember factoring means dividing. So we're going to divide 2 out of 16 and get 8. We're going to divide x out of x to the fourth and get x cubed. With the second term, we're going to divide 54 by 2 and get 27. And divide x by x, and that leaves us just with the 1, a multiplier of 1, which we don't need to write down. All right, so now let's look at what we have left in the bubble, this piece right here, and see if there's a way we can factor it. There's 2 terms. We have difference of perfect squares. Well, those are not squares, but we do have difference of perfect cubes. That's this new one right here. So looks like we're going to be able to use difference of perfect cubes. So let's kind of write our u and v out. So u, let's see, 8, it would be 2 cubed would be 8. So u is going to be 2x, and v, let's think about that. So what cubed would give me 27? Let's see, 3 times 3 times 3 would give me 27. So that's going to be 3y. Now we're simply going to put this one we already factored out here, and then we're just going to use the formula. Need a little bit more room here. We're just going to use the formula, and we're going to plug in those numbers. So in this formula, I've got a u minus v. So 2x minus 3y, that's my u minus v. Then I have u squared, so 2x squared would be 4x squared. Then we've got plus, now I'm supposed to multiply u times v, so 2 times 3 is 6, x times y is xy. Lastly, I am supposed to square v. V is 3y, so 3 squared is 9, and y squared is y squared. And again, with that factoring pattern, we are never able to factor this last trinomial out. It just won't work. So no sense in trying. All right, those are a couple of examples. Now let's look at here. We're going to solve this time. Here we were just factoring, but on 3 and 4 we're going to solve. Let's look at the difference between these. You'll notice this has an equal sign, this does not. If there is no equal sign, we are not allowed to add one. Okay, cannot add an equal sign. So here we go, solve by factoring completely. We want to factor completely. And we might have to use something else. It might not be completely factorable. All right, here we go. This is the sum of perfect cubes. So u would be x and v would be 4, because 4 times 4 times 4 is 64. All right, so let's use that factoring pattern. So that gives us x plus 4 times x squared minus 4x plus 16, and that's equal to 0. All right, great. So we set each bubble equal to 0. So x plus 4 equals 0, and x squared minus 4x plus 16 equals 0. This one is easy. Just move the 4 over. So x is negative 4. That's one of my answers. On the second, the trinomial, I have some options on solving. We've been talking about that for a while. Solving trinomials, we have quadratic formula, we have completing the square, and we have factoring. Since this is the second piece of a sum of perfect cubes, it's not factorable. So we're going to have to rely on either quadratic formula or on completing the square. Let's do quadratic formula for fun. So x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. All right, then we do our arithmetic, which gives us 4 plus or minus. So let's see, 16 minus a minus. Oop, that's a plus. Silly Billy, that's a positive. So let's see, we have 16 and then minus 4 times 16. That leaves me with a negative 48 over 2. So let's work on simplifying that. So 48 is 4 times 12, and that is what, 4 times 3, so I have a pair of 4s. And then this negative we know is I, so 4 plus or minus 4i root 3 over 2. If you recall from previous work, when we have a common factor in a v, we can factor that out. So 2 goes into 4 2 times. 2 goes into 4 2 times. And that's our second and third answer or solution. All right, one more. Oh, look at that one. Goodness, 128. Well, we know 2 and 128 are have a common factor of 2. So that gives me, what does that give me? That gives me 64x cubed minus 1. And yes, you guessed it, it is also perfect cubes. So 64 is 4 times 4 times 4. So u would be 4x and v would be 1. All right, let's plug into that factoring pattern. So that gives me 4x minus 1 times, let's see, 4x squared would be 16x squared minus, nope, it's plus 4x times 1, which is 4x, and then plus v squared, so 1 squared is 1, and that equals 0. Whew, okay. Let's see, so 2 equals 0, that's not helpful, so we just divide that off. So 4x minus 1 equals 0, so 4x is 1, or x is 1/4. This one we would use quadratic formula again, and we've done that so many times. I'm just going to give you the end result of doing quadratic formula. So we would work through quadratic formula and what we would get at the end. And I encourage you, if you would like to check it out, do quadratic formula, make sure you get this answer, -1 plus or minus I root 3 over 8. So there's one answer and there's the other two. All right, great. So that's our first piece. Let's go to our second page. Let's work some of these. Let's work all these. Oh, goodness gracious, there's a bunch of terms there, factoring. So let's, goodness, there's what, 6? So we need to try factor by grouping. I'm going to try to group the first 3 and last 3, see how that works. So let's see, what common factor do I have of the first 3? I've got a x squared, which leaves me x squared plus 7x minus 4. Okay, and let's see, the next set I have a common factor of a 2. That leaves me with 5x squared minus 14x minus 20. Okay, these bubbles have to match. The bubbles must match, and they don't. They don't match. So that means I need to reorganize and try again to see if I can get it to work. Okay, so I'm going to rewrite it. Okay, so let's see. Let's rearrange it. Usually what they do is they mix up these middle two. I don't know. Let's try that and see if that's what they did. So let's rewrite it as x to the fourth plus 7x cubed plus 10x squared, and then minus 4x squared minus 28x minus 40. Okay, let's try that. Okay, so our first, let's see, common factor, GCF, is x squared in the first three. So that's x squared plus 7x plus 10. Okay, let's see, in the next piece, it is a -4. So that leaves me x squared plus 7x. Ooh, looky there, plus 10. Our bubbles match. Oh, it's so slow. Sorry about that. Okay. Don't you love it when technology is just a little bit crazy? Okay. I know I have this dark pen blue. Then there we go. Goodness gracious alive. Trying to be fancy doesn't work when it doesn't follow you. So the bubbles match. Great. So, oh, now you're going to behave. Goodness. So that means that I can factor those bubbles out. They're the same. So I've got x squared plus 7x plus 10. And then I write down my leftover, which is x squared minus 4. Whew, that's pretty good. Now let's take a look at each of those bubbles that we have left and see if they are factorable. They certainly could be. This is a trinomial, this first one. Let's see if we can factor it like FOIL. So an x and an x. Let's see, the back sign is positive, so they're the same. 5 and 2. X times x is x squared. 5 times 2 is 10. 2x plus 5x is 7x. Yay, that factored. Now x squared minus 4, that's a binomial. That had a special factoring pattern of x, a plus b, a minus b. So x plus 2, x minus 2. And we have factored this little guy completely out. Whew. All right. Let's try one more crazy like that. So let's group together the first three and last three. Hopefully they didn't play a trick on us this time. All right, so the greatest common factor between the first three terms is a cubed. And that leaves me x squared minus 6x plus 9. Okay. Let's see. On the second one, the greatest common factor is b cubed. All right, that leaves me x squared minus 6. Oops. Come on, you can erase. I know you can. Plus 6x plus 9. Ooh, the bubbles match. We're in luck. So let's write the bubble out. X squared minus 6x plus 9. And then all the leftovers go in the second bubble. So a cubed minus b cubed. Whew. Okay, so let's see if those factor. Let's try to factor this one like FOIL. So an x and an x. The back sign is positive. Signs are different. Let's do 3 and 3. Negative 3x minus 3x is negative 6x. Okay, that checks. And this is definitely the difference of perfect cubes, so it factors a minus b, a squared, plus ab plus b squared. Whew. All right, so that is completely factored out. Okay, so now we're going to work on solving. They want us to solve by factoring. Now, this first one is a trinomial, and it is actually in quadratic form because 4 is twice 2. 2 times 2 is 4, and there's a plain number here. So that matches our template for quadratic form. So then I can factor it like a quadratic. So that would give me x squared. So x squared times x squared is x to the fourth. The back sign is positive, so my signs need to be different. Let's see, why don't we try, let's see, we want to get a -3, so let's put the 4 here and the 1 there. All right, very good. That does give us x squared, let's see, minus 4x squared plus 1x squared gives me a minus 3x squared. So that checks out. So now let's set each bubble equal to 0 and solve. Oh, this little guy can be factored some more. So x plus 2, x minus 2 equals 0. So we'll set those bubbles equal to 0. So we've got x squared equals -1, square root both sides. So x equals plus or minus I. And then x equals -2 and x equals 2. And those are our 4 answers. One more. All right, we have a trinomial. And let's see if it's in quadratic form. 2/3 and 1/3. So is 1/3 twice of 1/3? 2 times 1/3. Yep, it's 2/3. So, and I have a plain old number, so it is in quadratic form, which is just kind of weird, I know, with the fractions. All right, so if this helps you, if you'll look, see if it'll let me highlight, this term, whatever this term is what goes here and here. I mean, that's how it's going to work. So this term is what's going to go in the first spot. Let's see if it'll catch up with me. Come on, you can erase. There we go. Okay, so that's what goes here, r to the 1/3. If it's confusing, that's a way that you can always tell, r to the 1/3. Let's see, our back sign is positive, so the signs must be the same. They have to match this sign, so minus, minus. We want to get a -5, so let's try 2 and 3. So -2r to the 1/3 minus 3r to the 1/3 gives me -5r to the 1/3. Ooh, okay, got it. So now let's set each bubble equal to 0.